Section 4.2, Permutations and Combinations, Video 1. In this video, we will cover the following objectives. Calculate factorials and calculate permutations. We will begin with a definition. If n is a positive integer, then n factorial is the product of all integers from n down to 1. Symbolically, n exclamation point is used to represent this product. For example, if we wanted to compute 5 factorial, symbolically represented as 5 exclamation, we would find the product of all integers from 5 down to 1. So that would be the product 5 times 4 times 3 times 2 times 1, which ends up being 120. As another example, 1 factorial is the product of the integers from 1 all the way down to 1, which is just 1. And as a special case, 0 factorial is defined to equal 1 as well. That will come up often in calculations, so that is an important special case. Example 1. In how many ways can 8 bands be lined up to perform if one of the bands has been identified as the opening act and one of the bands has been identified as the closing act? So in this example, we could think about this as lining up 8 bands. So I'm able to draw 8 spaces to represent the 8 bands that will be lined up. One of the bands has been assigned to be the opening act, so there is only one possibility to fill the first spot in the lineup. And one of the bands has been identified as the closing act, so there is one band that will fill the last spot in the lineup. So out of 8 bands, we have already placed 2 in their respective places. This would leave 6 bands left over that could potentially fill the second spot. Out of those 6 bands, one of them will get selected ultimately to fill that second spot, which would then leave 5 bands that could fill the third spot. And again, out of those 5 bands, ultimately one of them will be chosen to fill that spot, leaving 4 bands to fill the next spot. The rest of the spots are filled in this same manner, continuing decreasing by 1 each time. According to the fundamental counting principle from section 4.1, we're able to multiply these possibilities to get the total number of possible lineups. Multiplying gives an answer of 720. So there are 720 ways that 8 bands can be lined up to perform if one band has been identified as the opening act and one band has been identified as the closing act. This can be written in a more concise manner. We have 1 times, and then the product 6 all the way down to 1 can be written 6 factorial, and then we're going to multiply by the 1 band at the end. So this can be written as 1 times 6 factorial times 1, which gives a result of 720. This is an example of a permutation. A permutation is an ordered arrangement of items in which order matters and no item can be used more than once in the arrangement. This brings us to the definition of permutations. A permutation is a way in which a set number of items can be arranged. In a permutation, no item is used more than once and the order of arrangement matters. Here's another example of a permutation. Suppose a softball coach wants to know the number of 9-person batting lineups that can be created from a team of 15 players. This type of problem can be solved using the fundamental counting principle by multiplying the number of options for each spot of the lineup, as was done in the previous example. This is an example of a permutation. So just like in the example before this, I am able to draw out the different spaces, and then I can fill in the options. So we have a 9-person batting lineup. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And there are 15 different players that could fill the first spot in the lineup. Ultimately, a player will get chosen to be first, which would leave 14 players to choose from for the next spot. And as before, this continues on, decreasing by 1 each time. And by the fundamental counting principle, we are able to multiply these different possibilities to find the total number of possible 9-person batting lineups. Multiplying the integers from 15 down to 7 gives an answer of 1,816,214,400. So that is how many different 9-person batting lineups that can be created from a team of 15 players. Now, to develop a formula for permutations, we will use this example. Notice that the calculation that was just performed is the same as if we took 15 factorial and divided it by 6 factorial. And notice how this would work, because if we took 15 factorial and we divided it by 6 factorial, we would get the same calculation as was done above, because we would be able to simplify by canceling 6 factorial from the numerator and from the denominator. And so a shorthand way to come up with this same result would be to simply take 15 factorial and divide it by 6 factorial. Now, where does the 6 factorial come from in this problem? Well, notice that we have 15 players to choose from for this lineup, and we are creating a 9-person lineup. If we take 15 factorial and divide it by the factorial of 15 minus 9, then we would get 15 factorial divided by 6 factorial. So the numbers present from the problem are actually appear in this calculation. 15 is the total number of players. And if we're selecting 9 of those players, then in the denominator, we would do 15 minus 9 and then find the factorial of the result. So this basically gives us a formula for computing permutations. And before we go through the formula, I just want to talk about some notation. The number of permutations of 15 players taken 9 at a time is represented by, or is given by, P and then in parentheses 15 comma 9 or 15P9. So both of those are symbolic ways to write this permutation. In general, the number of permutations of R items from a collection of N items is symbolized as P and then in parentheses N comma R or NPR. The batting lineup example that we just completed we just generalized it to write a formula for calculating permutations. This brings us to the permutation formula. The number of permutations of R items from a collection of N items can be calculated as follows. N factorial divided by the quantity N minus R factorial. In example 2, we will practice using the permutation formula to calculate given permutations. Part A, we will find the permutation 10 comma 4. So according to the permutation formula, we will take 10 factorial, and then we will divide that by the factorial of the difference of 10 and 4. So in other words, 10 minus 4, and then find the factorial of that. 10 minus 4 in the denominator gives me 6. So this is 10 factorial divided by 6 factorial. Now, we can write out 10 factorial. So that's 10 times 9 times 8 times 7 all the way down to 1. And then we're dividing that by 6 factorial, which is the product of the integers from 6 down to 1. And as we've done before, we notice that we can simplify by canceling a 6 factorial from the numerator and the denominator. So in other words, 6 all the way down through 1 will cancel in the numerator and the denominator. And so I'm left finding the product 10 times 9 times 8 times 7, which gives me an answer of 5,040. Part B, permutation 7, 7. So we will take 7 factorial, and then in the denominator, we are going to subtract 7 minus 7, and then find the factorial of that. Well, 7 minus 7 is 0. So we have 7 factorial divided by 0 factorial. 7 factorial is the product of 7 down through 1. And as mentioned earlier in this video, 0 factorial is a special case, which is just equal to 1. So we're left finding 7 factorial divided by 1, which gives 5,040. Notice how we got the same result in part A and part B, and these are different factorials. So this shows that different factorials can produce the same output. Example 3. 15 runners are competing in a 10K race. In how many ways can the first 3 finishers come in, assuming there are no ties? This is an example of a permutation because it is an ordered arrangement of items in which the order matters and no item is used more than once. So in other words, when we're looking at the first 3 finishers, first place, second place, and third place, the order in which these runners finish matters. And no runner is going to occupy more than one place in this example. So this is an example of a permutation. We essentially want to calculate the permutation, the number of permutations of 15 runners taken 3 at a time, which can be symbolically represented as P 15, 3. According to the permutation formula, we would do 15 factorial divided by the quantity 15 minus 3 factorial. 15 minus 3 is 12. So when working on this calculation, we can write 15 factorial, so the product of the integers from 15 down through 1. But I am going to show a shorthand way to do this. Instead of continuing on here like I normally would, I am going to write 12 factorial. So that implies that I would keep going. 12 times 11 times 10 all the way down to 1. But it's just a shorthand way to write this so that I don't have to write that entire product out. And then in the denominator, we have a 12 factorial as well, which would be the product 12 times 11 times 10 all the way down to 1. And just as we've done before, notice that the 12 factorial in the numerator and the denominator would cancel if we were to simplify, which means that we would end up with 15 times 14 times 13, giving a final answer of 2,730. So there are 2,730 different ways that the 3 finishers can come in from a group of 15 runners. Now notice, this would give the same answer if I simply drew spaces like I had done in the past. So if we look at the first 3 finishers to finish the race, there are 15 runners that could potentially finish first. One of them ultimately will, which would leave 14 finishers that could finish second, and one of them ultimately will, which would leave 13 finishers or runners that could finish third. The fundamental counting principle says that we would multiply, and notice that we would obtain the same result. This concludes example 3.